NASA's James Webb Space Telescope has barely woken up, and the universe is now more baffling, more gorgeous than mankind's dreams. Biden has presented the first picture to be shown freely from the James Webb Telescope. Since telescopes can assemble all the more light than the human eye can see, they have improved our capacity to observe the stars. Various equipment has been created throughout the years to further our understanding of space, but none have accomplished the kind of advancements that the James Webb Telescope has. It has been illustrated that this telescope can go back in time to the universe's beginning. Everything changes now that we have the officially clearest photo of the City of Lights ever seen. 18 distinct images, one for each mirror, are what we expect. Let's talk about this surprising new finding from the James Webb Telescope and its possible ramifications for the future. This is no ordinary telescope. This magnum opus of human creation is the greatest and most powerful space telescope ever built, and its objective is to change our understanding of the universe. Researchers can travel back to a moment when the universe was only 200 million years old thanks to the advanced hardware of the JWST. We will have the option to return to the past in the universe with the help of this creation's data. Furthermore, the telescope can take photos of some of the oldest galaxies that have ever existed, showing the first stars in the universe sparkling in the completely dark cosmos. NASA announced that the James Webb Space Telescope would concentrate on 4 essential subjects: the first light in the universe, the formation of galaxies in the early universe, the development of stars and protoplanetary systems, and planets including the beginnings of life. These objectives have been challenging to achieve due to the difficulties in obtaining clear views of space, but they are fundamental for the study of the universe. Consequently, it has been pivotal to gather as much data as possible and then utilize the best minds to assess that information. Basic science and alignment tests were conducted on the telescope before it began its galactic observations. The sun shield, a sizable 5-layered fabric, protects the telescope's sensitive instruments from the sun's heat and light. This sun shield was deployed during one of the main tests to ensure that each layer was accurately tensioned and aligned. This deployment needed to be done precisely. Any misalignment or damage to the sun shield could make it difficult for the telescope to see distant objects. Luckily, it completed this assessment and progressed to the next one. The telescope itself needed to be aligned to provide a sharp image. The 18 hexagonal segments that make up the JWST's primary mirror had to be precisely adjusted. This process involved gradually deploying the primary mirror, extending the adjustable support structure, and unfurling the sun shield. The mirror required precise alignment for scientific observations. Any mistake in this procedure would be equivalent to discarding more than $1 billion. To ensure that all the telescope's scientific instruments were functioning properly, another critical alignment test involved turning each one on separately. These instruments, which have various functions for studying the universe, include the mid-infrared instrument. The close-to-infrared spectrograph and the close-to-infrared camera are crucial components of the James Webb Space Telescope, JWST. In conclusion, the telescope had to be precisely situated in space to see its objective objects. This ensured that the telescope's pointing and global positioning frameworks were directed at the right focuses on this system, known as dispatching. Observing adjustment targets were used to ensure the JWST was in great working order and ready to begin its mission of investigating the universe. These tests were fundamental, and researchers were becoming increasingly invigorated as these complicated activities were performed successfully. The JWST was completing each assessment with flying colors, which was astounding. The JWST project involves nearly 300 universities, associations, and organizations from 14 countries, as well as 29 U.S. states, making it a truly global undertaking. After passing every test that NASA could throw at it, the James Webb Space Telescope was officially cleared to begin its extraordinary scientific mission in July of 2022. NASA announced that the JWST was ready to start its investigation mission after all 17 of the observatory's scientific instrument modes had undergone thorough testing. The primary capability of the JWST, like any other telescope, is to gather light and focus it so that we can see distant objects. However, the area of the electromagnetic spectrum that the JWST observes distinguishes it from other telescopes. The JWST operates in what is akin to the heat-producing infrared range, while the human eye only detects visible light. Think of it as the universe's equivalent of a high-tech reconnaissance camera with night vision. Smaller and farther-off objects can be seen thanks to the JWST's ability to gather significantly more light than traditional telescopes due to its immense size. Furthermore, because it is in space, it is not affected by atmospheric interference, which can obscure vital data, giving it the moniker Eyes on the Universe. The colossal 21-foot mirror on the JWST collects light and reflects it back to the spacecraft's instruments. It features 4 devices, each designed to capture a specific type of light and offer a particular perspective on the universe. The primary camera, the near-infrared camera, is used to take stunning pictures of distant galaxies, nebulae, and other celestial wonders by analyzing light into its individual colors. The near-infrared spectrograph provides additional insights about the objects it studies. Dedicated to capturing infrared light, the mid-infrared instrument aims to investigate the early universe, exoplanets, and our own solar system. Finally, the near-infrared light-sensitive fine-guidance sensor, near-infrared imager, and slitless spectrograph are used for precise pointing. Because infrared radiation has longer wavelengths than visible light, it can reveal information that would otherwise remain hidden. NASA chose to utilize it with the JWST since most infrared light that reaches Earth is blocked by our atmosphere and must be observed with a specialized telescope like the JWST. Light from the farthest reaches of space shifts toward the red end of the spectrum as the universe expands, allowing us to peer into the early universe and observe the formation of stars and galaxies, as well as learn about the conditions that prevailed at that time by studying the universe in this redshifted light. Because the JWST can look so far into the universe, it can also look back in time. Light travels slowly, and when the JWST observes a distant galaxy, it sees the universe as it appeared billions of years ago when the galaxy's initial light was emitted. This capability enables researchers to investigate the early universe and discover the elements that gave rise to the modern universe. On July 12, 2022, during a live event, NASA revealed the first science images from the JWST, dazzling views of the universe. Stunning images of the grandiose cliffs in the Southern Ring Nebula and the Carina Nebula were captured in these photographs. A glimpse of Stephan's quintet, a grouping of merging galaxies, and an assessment of the hot gas giant exoplanet WASP 96b's atmospheric composition were also made possible by the JWST. Due to their beauty and scientific significance, these photographs generated a lot of excitement and energy. The assessment of the atmosphere of WASP 96b provided insights into the components governing the birth and evolution of exoplanets, while the JWST's view of Stephan's quintet yielded new information about interactions within the universe. The first JWST science quality image was disclosed on July 11, 2022, by NASA Administrator Bill Nelson, Vice President Kamala Harris, and President Joe Biden, using just 12.5 hours of observing time on one of the telescope's 4 instruments. This image represents the deepest infrared view of the universe to date. NASA announced in February 2022 that the JWST had taken its first images of stars. The star HD 8446 was represented by a mosaic of 18 scattered bright spots. Thomas Zurbuchen, NASA's Associate Administrator for the Science Mission Directorate, expressed on Twitter that these 18 dots will ultimately converge into a single star once the JWST adjusts and focuses. This significant achievement illustrated the telescope's capabilities and potential for future research. In the following weeks, the JWST's progress continued, and NASA released an enhanced and new photo of HD 8446 on February 18. The observatory strategically arranged the 18 unfocused duplicates of the star into a hexagonal shape to provide a better representation of the final image after the various adjustments were made. Portions of the essential mirror were accurately adjusted. Researchers had the option to get a clearer, more detailed picture of the star because of superimposing 18 photographs over each other using a particular camera built within the NE-CAM gadget for arrangement and technical purposes. Webb also captured a remarkable selfie since only one mirror segment was effectively adjusted and focused on a star at that specific moment. The picture revealed that segment to be brighter than the others. If all the mirror portions were accurately adjusted, it would exhibit the surprising exactness and accuracy of the telescope. Looking further into the bird cloud, with its tremendous sections of gas and dust venturing into space, was one of the telescope's most significant revelations. Despite being able to capture the construction's gloriousness, the Hubble Space Telescope couldn't uncover their mysteries. The pillars of creation in the bird cloud are home to hidden star formation that has been revealed by the James Webb Space Telescope's infrared imagery. Webb's latest preview uncovered a large number of protostars as minuscule red spots on the backdrop of the cloudy foundation. Stars are born in these massive agglomerations of gas and dust, each multiple times larger than our planetary system. These youthful stars are not yet consuming hydrogen. According to Derek Ward-Thompson, a senior dean at the University of Central Lancashire in the United Kingdom's School of Natural Sciences, the core gets denser over time as additional material falls in, and eventually hydrogen burning begins, increasing the temperature to approximately 2 million degrees Celsius. The actual picture is a marvel, addressing generally imperceptible infrared frequencies with an assortment of colors. According to Anton Kamer, a research cosmologist at the Space Telescope Science Institute in Baltimore, the picture's visible segments appear blue, although they would seem red to the untrained eye. Significant insights about star development, including that of our Sun, are shown by the photo. Images like this one, according to Ward-Thompson, not only showcase Webb's true potential as an infrared telescope but also shed light on the beginning stages of star formation and how they change over time. The direct imaging of exoplanets was one of the unanswered mysteries. The first exoplanets were found circling distant stars in the early 1990s. The planets were identified by their passing in front of the star, which caused a minor dip in the star's light. With its modern equipment, like coronagraphs and exceptional sensitivity, the James Webb Space Telescope might have the option to take direct pictures of exoplanets in under a year after launch. Webb achieved a significant milestone when it captured the first direct image of HIP 65826b, an exoplanet that was discovered in 2017 and is multiple times further away from its host star than Earth is from the Sun. Researchers combined images of this massive gas giant using many filters and 2 of Webb's cameras. Astronomer Sasha Hindley of the University of Exeter in the United Kingdom stated that this was a turning point for Webb and astronomy in general. Webb found it easier to photograph HIP 65826b due to its huge size and distance from its host star, which makes it multiple times bigger than Jupiter, as well as producing stunning images. Direct imaging of exoplanets adds to our understanding of the universe's origins and the potential for additional solar life. These photos may reveal information about the composition of planets' atmospheres and how they form, which could help in finding exoplanets that are habitable. If a livable exoplanet exists, Webb might be the first to find one due to its close observations of exoplanets. Even more striking than all of that was the next announcement, Webb's observation of the oldest galaxies known to humanity, which began when the universe was only 2% of its current age. This achievement was declared a success by researchers. These 4 galaxies are roughly 13.4 billion light-years away, making them the most distant yet seen as part of the JWST's Advanced Deep Extragalactic Survey. Webb was able to identify these ancient galaxies by detecting even the smallest signs, thanks to its infrared capabilities. The team measured the redshift of these galaxies using data gathered by the near-infrared spectrograph to confirm their age. These galaxies are confirmed to be the oldest ever observed, with a redshift of 13.2, the highest ever measured. This finding could significantly alter our understanding of the universe by providing a window into its early stages. Researchers have recently become interested in one intriguing possibility. The telescope might be able to produce the clearest picture of city lights in recorded history. Proxima b is a planet that is in Proxima Centauri's habitable zone. Proxima Centauri is a red dwarf star that is 4.25 light-years from Earth. In the unlikely event that Proxima b is home to an advanced civilization, photovoltaic cells might be used to power lights on the night side of Proxima b. City lights may be visible to the James Webb Space Telescope if artificial light is confined to a frequency range that is smaller than that of starlight. There will be even fainter artificial lights on Proxima b that future space telescopes, like NASA's projected Large Ultraviolet Optical Infrared Surveyor, will be able to identify, potentially leading to the discovery of city lights on a planet over 4 light-years away. This serves as a reminder that much more has to be learned about the universe. We have drawn one step closer to understanding our solar system and distant worlds with the help of observatories like the JWST. Do you believe that all of science's questions can be answered by the James Webb Space Telescope? Or do we still need bigger telescopes? Let us know in the comments section below. Please hit like if you enjoyed this video, and we'll see you in the next one.